Welcome to the second lecture of the course. Here I'll be presenting the main non-destructive testing technique used in the industry. So we'll start first by the penetrant testing. The principle of the penetrant testing is to apply a penetrant to the specimen. So as you can see here, this is the specimen with a crack, and we apply a penetrant on the surface. Of course, the surface should be cleaned before. The second step, we have to wait for the liquid to be pulled into the defect by capillary action. You can see it here. And then the excess of penetrant is cleaned from the surface. So remove the excess penetrant, and then we apply a developer. The purpose of the developer is to pull out the tripped penetrant back to the surface. So here is the developer, and then the excess of penetrant is pulled out, and we can see the indication. In this table you can see the advantages and limitations of this technique. So it's a low-cost technique and portable technique, and the indications may be further examined. The limitations are that the defect must be opened to the surface, otherwise we cannot see it if it is not opened to the surface. And then the part of the specimen must be cleaned before and after the test. And if there is a surface film such as coating, it may mask the defect. Let's see another technique, which is the magnetic particle testing. First, magnetic field is established in the component, and the component of course should be made from ferromagnetic material. So the arrows here represent the magnetic field, and the magnetic lines of force travel through the material and exit and re-enter from the poles. The defect cannot support the flux, and it forces some of the flux outside of the part, as you can see here. The magnetic particles distributed over the component will be attracted to areas with flux of leakage and produce a visible indication. And here also the advantage of this technique are that it is low cost and portable technique, and it gives indication of subsurface defects. The limitation that the specimen should be made of ferromagnetic materials. The alignment of magnetic field is very critical, and the magnetization required after the test, and also the surface coating can mask defects, and also we need to clean the specimen before and after the test. Now let's see the ultrasonic testing technique. The main principle of this technique is to generate a high frequency sound wave inside the material. So as you can see here, we have a specimen with a flow, and this transducer generates sound waves of high frequency. The sound waves travel through the material and are received by the same transducer, or sometimes we use a transmitter and a receiver, so the waves can be received by another transducer. And the amount of energy transmitted or received and the time required by the wave to travel through the material is calculated and analyzed by the ultrasonic system. Changes in material thickness and changes in material properties can also be measured by this technique. Here are the main advantage and limitation of the ultrasonic testing method. So it is most sensitive to cracks, and it gives immediate results, and its automation is possible, and it gives also a permanent record of the defect, and it's also a portable technique. The limitation, a couplant is required, and complex geometry or small parts may be difficult to check, and reference standard and block are required, and also it needs trained operators and special probes. Now let's see another technique, which is eddy current testing. Alternating electrical current is passed through a coil producing a magnetic field, as you can see on the picture. When the coil is placed near the conductive material, the change in magnetic field induces current flow in the material, as you can see here. These current, of course, travel in closed loops and are called eddy currents. So here, as you can see, the eddy current are represented by the green arrows. Eddy currents produce their own magnetic field that can be measured and used to find flows and characterize conductivity and permeability and dimensional features. The advantage of the eddy current technique, it's a high-speed technique and low cost, and also it gives permanent record, and no couplant, no probe is required. The limitation, well, it should be used only on conductive material and shallow depth of penetration. Now let's see another technique, which is the radiography testing. First, X-rays are used to produce image of object using film or other detector that is sensitive to radiation. So as you can see here, the source of radiation that generates the X-ray which are used to produce image. The test object is placed between the radiation source and the detector or the film. Here is the test object, which is placed between the radiation source and the detector. The thickness and the density of material that X-rays must penetrate affect the amount of radiation reaching the detector. So we have the generated radiation, which comes from the source of radiation, and we have a small amount received by the detector. This variation in radiation produces an image on the detector that often shows internal features of the test object. Here are the advantage and limitation of this technique. So it is portable, and it gives also permanent record, and geometry variation does not affect the direction of radiation. But in the other side, there is a radiation hazard, and it is expensive, and it requires trained operators, and some linear defect may be missed, and the depth of the defect is not indicated, and access is needed to at least two sides of the part or the specimen.